We have already witnessed in our previous classes about public key crypto system, as well as just a basic idea about the symmetric key crypto system. So in public key crypto system, we have already witnessed RSA as well as El-Gamal public key crypto system. And there we have already seen or witnessed few efficient algorithms generate very large prime. So large prime, very large prime means prime number having around 1,000-digit long prime numbers. And believe me, in our class, we have already seen that how to generate that big primes even at your own laptop or desktop very efficiently, very easily, maybe within 30 seconds. So with these passwords or these big prime numbers, what we usually do, that one of the places that where we use those things is RSA or El-Gamal public key crypto system. But there are other places. For example, there is no doubt that in today's scenario, every day we use a lot of internet for many places or many reasons we use internet. For example, usually when we get up in the morning, usually the first thing usually we do is checking our emails or WhatsApp or maybe Facebook account, etc. So wherever you do those things at the very initial step, you have to register at those WhatsApp or maybe at any of these applications. Then you have to register by using your some password or email ID. Or sometimes we use our internet for buying something online. So there also we need to give the information about our credit card details or debit card details. And at the end, you have to put some PIN or some OTP. So everywhere we need to have some password kind of things. So the best thing is that if we can remember all those passwords at our brain, but now you can understand that with the advancement of science and technology, these passwords are becoming more and more complex. So initially when it started, usually we had only alpha and numeric, that means alphabets as well as some number. But nowadays the password must contain some of the special characters like @ etc. So now you can understand that day by day the nature of the passwords is becoming more and more complex. And in case of banking sector, if you see that the bank, they actually force you to change your, modify your password maybe in every 3 months or maybe in every 6 months. Now, when you reuse the password, or say maybe the last password that you used, if you re-enter the password for a new password, it says that you have already used. Maybe it can go up to last 10 used passwords. So you have to generate new and new complex password every day. And it's really difficult for us to remember all those passwords. And so it's not always possible to remember all those passwords or keep all the password at our brain. Not only for practical purposes for our but if you go beyond it, for example, if you go to the how the data are being stored by Google, if you have a look at, so this is taken from Google website itself. So it says that if you suppose you want to store this chunk data, and this data are being then stored in the Google website, in the Google server, but before storing the data is being encrypted by some key. Okay, so these keys are used to store this data. So suppose this amount of data you want to store at some Google server. First, it is being chopped, or it is being sliced by 3 pieces, and each of these pieces are being encrypted by 3 different keys. It says that even if the same data is being coming from a same chunk of data, for each chunk, each individual chunk, these keys will be different. And then each of the encrypted data are being stored separately or differently at some different servers of Google. Now it says that not only that, to have the security of individual keys, each of these keys are then being encrypted by another key known as a key encryption key, KEK. So these keys are being again encrypted by another key that is known as key encryption key, and that key is being stored by Google Key Management Service. Okay, so the Google's Key Management Service, KMS. So if you want to look into in more details, you can go to the web page of Google and you will find all the details. And while doing so, Google uses this kind of primitives, for example, AES 256. So this is an example of a symmetric key, and this is an example of a block cipher. Okay, so it's very famous. Another thing is that elliptic curve signature algorithm, or maybe RSA 3072, etc. So we have already seen RSA, and it is 3072 means the number of bits to represent the primes are around 3072. So the prime will certainly contain around 1000 digit long prime. So one of the example could be this. So this is an example of a whole bit prime, and it consists of 904 digit long. So in our previous classes, we have already mentioned how to generate this big prime very easily at your own laptop. Now you can understand that in case of RSA, if the primes are this big long, then what could be the private key size? That means the decryption exponent. So that would be around, say, maybe 2000 digit long. So nobody in the world can remember that bit long prime number. They cannot remember it. So you have to store it somewhere. Now, if you store the whole password in single place, then what may happen if that place is being corrupted, or that is being compromised, or maybe attacked by some virus, then it would be a single point failure. That means if the one place is being destroyed, then the whole the key will be destroyed, and you can understand that there is no other way to decrypt the message. So one possible solution could be you can store the whole thing in different places. The same key could be stored in different places. Now you can understand that if you store the same thing at different places, then the possibility of losing the data will be even higher. So if one of them will be compromised, then your data will be lost. So the compromisation of any of these places will certainly lead to the losing the data, or the security of the data will be lost. So the question is then what to do? So one of the important primitives that are being used for storing the data securely is known as secret sharing. So now let us try to explain what do you mean by secret sharing. Suppose here there are three, say, good looking friends, and from their dresses it's quite easy to understand what could be their profession. So whatever income that they are going to have, they put all their incomes into that box. But since they are very honest, they do not believe each other. That means one friend has no faith on other. So what they do, they decided a kind of protocol. So they thought that, okay, the locker or the box can be opened only when if at least two of the three friends, they agree to open the locker or to open the box. That means among these three friends, in cryptographic sense, we call these friends as participants, and the lock, we call it as key. For example, in case of a digital lock, this could be a password kind of thing. So in cryptographic sense, we call the lock as key, and each of these participants or each of these friends are known as participants. So they require some special kind of lock and key. So they will have three lock and key in such a way that if at least two of the three locks or three friends, they agree to open the lock, that lock could be opened. So a special person in cryptography, we call him as dealer. So the dealer is going to give each of the keys to each of these participants in such a way, if at least two of them they agree to open the locker, they will be able to open this, but it should not be possible for a single friend to use a single key to open that box. Okay. So after giving this lock and key, the dealer will disappear. So that is a quite reasonable thinking, because usually when we go for a, say, holiday or for a vacation, then usually we put a very strong lock and key at our gate. So you understand that this lock and key can be certainly be opened by the owner of the lock and key. So the company who produces that lock and key, there must be some replica of the same lock and key. That means the owner of that lock and key will, the company of the owner of that company will certainly have a replica of that lock and key. But we assume that certainly that owner will not be able to come to open my house by using that replica of the key. So that means the dealer here after giving the lock and keys to each of the participant, the dealer will disappear and he will not again appear for any of the further future opening of the lock and key. So that's the reasonable justification. But this scheme is basically known as or generalized as this term known as TW threshold scheme. So here W denotes the number of participants. So in my previous example, the number of participants or friend were 3. So here W is 3 and T is the threshold value. That means minimum how many number of participants are required to open the lock. So in my case, there are at least 2 friends are required to open the lock. That means the threshold value should be 2. That means if you are less than the number of threshold value, that means T minus 1 or less, then the lock cannot be opened. But if T or more number of participants will join to open the locker, they can open the locker. So that is known as TW threshold scheme. So you might have seen the application of this threshold scheme or secret sharing scheme in while opening the bank locker. So usually when we go for a bank for opening the locker, then you see that there are 2 keys for opening that locker. One key is staying with the customer and there is one key with the bank management. So when you go for opening the locker, somebody from the bank will accompany you to open the locker. Both of the keys are used. If both of the keys they match, then only the locker should be opened. That means it should not be possible for a bank manager or somebody from the bank to open the locker alone. At the same time, it should not also be possible for a customer to open the bank locker. So here you are using basically the 2-2 scheme. That means 2 participants are there, one manager or maybe some person from bank and another one is the customer. If both of them they agree to open the locker, then only the locker could be opened. Another possible application could be the launching of missiles. So you can understand that for powerful missiles, while launching these powerful missiles, they are basically guided by satellites and the whole thing could be guided by some computers, mostly some laptops or maybe some powerful machines and something. So to get access of that laptop, the password is being shared among say maybe 3 participants, say maybe the prime minister or the president of that country, maybe the chief of the defense or maybe the defense ministry. So if at least 2 of them they agree to launch the missile, then only the missile could be launched. So that's quite practical to use for long or very powerful missile. Not exactly secret sharing scheme, but the concept is quite similar here. Suppose when we get our ATM or maybe a credit card for the first time, so usually the credit card or the debit card, they usually come to us through some post. So some postman or some courier, they usually gives it to us. And after few days, the PIN to use that ATM or the debit card, it comes. Nowadays, though the bank has stopped this kind of method, nowadays if you have your ATM or debit card, then you have to either go to the bank or go to the ATM to generate the PIN. But around 2 years back itself, it was a method that when the password as well as the card, they do not come to you simultaneously. They usually come one after another. Initially, you get your physical card and then after a few days, the PIN usually comes to you. Another similar kind of thing is that when we buy something using our online credit card or debit card, so you need to put all the details of your card into the say some portal and then it generates some OTP and the OTP comes to your registered mobile, and when you put the OTP then only the product can be purchased or something can be done. That means here the whole thing is, if you say that the buying things is your main goal, then the whole buying thing is being distributed first by delivering the card details and then giving the OTP at your machine. Then only the whole thing can be done. So the question is how to implement or how to have a secret sharing scheme. Okay. Let us give a very simple example of a secret sharing scheme. Suppose the password is Japan and he is the dealer and he wants to give the password among this boy and this girl. Suppose he has given Jap to this girl and N to this boy. Okay. Now, if both the boy and the girl will come together and suppose she puts her password first and he gives his password second, then after giving both of their password, the password will become Japan and they will able to access whatever they want. Okay. But if you look it very carefully, then you understand that this scheme is not a very good scheme. Question is why? Suppose this girl comes to know that after giving her password, the boy will join to give his password, and the password is say 5 alphabet long, 5 character long, and the boy is going to give only the uppercase. So that information suppose the girl has. Then the question is, in how many choices the girl will able to get the whole password. Now you can understand that in that case, the password length is 5 and the girl has already this information. So the girl does not know about only the last 2 alphabets, and suppose she comes to know that there are only 5 alphabets and all the alphabets are in uppercase. Then for this place, she has to guess only 26 many options, and for this place, she has to guess only 26 many options. That means altogether, she has to guess 26 square many options. That means after guessing 26 square many options or after trying 26 square many options, she will certainly get the whole password. That means the girl has 60% information about the password. On the other hand, if the boy will come and if the boy will able to know that the girl will first provide her password and all the password characters are in uppercase and the length of the password is 5, then for the boy is also the similar calculation. He has to guess only the 3 alphabets and then he knows this part. So that means he has to guess only 26 cube many options. So he knows the 40% information about the password. That means in this scheme, that's why we cannot say that this scheme is a good one, because about the password, the girl knows 60% information, and about the password, the boy knows 40% of the information. So the question is it really possible to construct a secret sharing scheme in which the boy and the girl will not get any extra information? That means 0% in extra information about the password, even if the boy and the girl will have some kind of shares. So each of this part of this password, we call it shares. Okay. So let us now try to construct such a scheme. Okay. So suppose my password here is in binary. So 011 010. So my password is in binary 011 010. So there are 6 binary characters here, zeros and ones. So the dealer wants to distribute this password among this girl and among this boy. How and what to do then? So the dealer will first choose an unbiased coin. That means some simple coin for tossing. So we know that the probability of getting head and tail is exactly half for an unbiased coin. So probability of say getting head, so I am considering this is as a coin tossing, t equal to say head. If I consider head to be 1 and tail to be 0, then the probability of coin tossing t to be 1 is exactly half as the probability of getting t to be 0. Okay. What the dealer will do, the dealer will, since the length here is 6, what the dealer will do, the dealer will toss the coin 6 times. So he will get some sequence of zeros and ones, that means sequence of heads and tails. Suppose he gets this sequence 0 1 0 0 1 1, that means 0 1 0 0 1 1, that means tail head tail tail head head. Okay, so he gets this and then he converts by using this rule, he converts it into binary. Okay, now she gives this the dealer gives this binary string. So this is a random string, right? So it's an outcome of the experiment of coin tossing. That's why this is an by and some unbiased coin. So this is an random strings of zeros and ones, and this string has 6 zeros and ones. So he gives this to the girl as the share. That means 0, 1, 0, 0, 1, 1 is given to the girl as the share. Now the question is, what will be given to the boy? Now he will do some mathematical operation. For example, this is my secret 0, 1, 1, 0, 1, 0, and this is the outcome of the random experiment of tossing the coin for 6 times. Now what he is going to do, he is going to make a bitwise OR operation, bitwise XOR operation, XOR operation. So for engineers or for IT people, XOR operation is quite easy. So if you have this truth table, so 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is again 0. For mathematician also, this is very easy. This is nothing but addition modulo 2. So we know that Z2 plus is a group, and if you consider this as an element of Z2, then if you just make an addition modulo 2, the same thing will happen. 0, 0 gives you 0, 0, 1 gives you 1, 1, 0 gives you 1, and this is 1 plus 1 becomes 2, and in Z2 that becomes 0. So XOR and addition modulo 2 are exactly the same thing. Okay. So the dealer will do basically the bitwise XOR operation with these two strings. So what he will get? He will get 0, 1 is 1, 1, 1 becomes 0, 0, 0 becomes 0, 1, 1, 1 0 becomes 1, 1, 1 becomes 0, 0, 0 becomes 0. So after doing the bitwise XOR of these two strings, whatever would be the output would be given to this boy as his share. Now this boy and girl, they will have some shares of 6-bit long. Now you can understand when both of them, they will make an XOR of it. For example, here the girl has this one, 0, 1, 0, 0, 1, 1. So this is the girl's share. And what is the boy's share? 0, 0, 0, 1, 0, 0, 1. Okay. So 0, 0, 1, 0, 0, 1. So this is the boy's share. Now if you make an again bitwise XOR of it, what you will get? 0, 1, 0, 1, 1, 0. And that was the secret, 0, 1, 0, 1, 0. So that was the secret. So if both of them, they will put their shares and give the XOR operation bitwise, then they will get back the secret. That's fine. But the question is, as I claimed just now, that both this boy and the girl will not have any extra information. So how do you prove that? Okay, to do that, let us just do some very basic, simple probability calculation. Okay, so just now we have seen that the probability of tossing 0 and the probability of tossing 1, that means tail and head, is exactly half. Okay. Now suppose this is the my secret, and suppose there is some probability distribution over this secret. That means suppose my secret, the probability of secret to be 0, say p. Okay, the probability of one of the bit to be 0, say, is p. Then the probability of h to be 1 will suddenly be 1 minus p, since this is a binary random variable. So the secret bit is either 0 or 1. If this is p, then this secret bit to be 1 should be 1 minus p. Now what I am doing with this secret bit, I am making an XOR of the output of a coin tossing. Okay. Now I want to find what is the probability of tossing XOR the secret to be 0. That means what is the output of if I make a bitwise XOR of these two, and if I want to find the first bit of this, what is the output that this should be 0. Now the question is when that will be 0. In XOR, when both of them are of the same size, that means if both of them t should be 0, s to be 0, or t to be 1, s to be 1. That means probability that t to be 0 and, that means multiplication, probability s to be 0, or that means plus probability that t to be 1 and multiplication, probability s to be 1. That means both of them are 1, then only it could be 0, or both of them they are 0, then only it could be 0. Now, if I put this value, probability of t to be 0 is half. Half into s to be 0 is p plus half into 1 minus p. And if I make half common, then p minus plus 1 minus p, and that becomes 1. And that's a very interesting observation. That probability of this is exactly half. That means that becomes random. So it's one of the very most interesting part is that suppose you have any say binary random variable, that means it takes either 0 or 1 with some probability distribution. But if you are making XOR with any random, so that is random, right? Because the probability here is either 0, I mean probability of this to be 0 or 1 is exactly half. That means this is a random event. If I make a XOR with any random variable which is satisfying this property, this means probability of this is half, then whatever be the probability distribution of S, that becomes random. Okay. That is very important observation, and this fact is very much used in case of stream cipher as well. So when we'll talk about stream cipher, we'll also see the similar kind of property. That means whatever be the probability distribution of S, it does not matter if it is being XORed with a random variable which satisfies this property. That means this is uniformly distributed. If this is kind of uniformly distributed, then if it is XORed with whatever be the random variable, then that becomes also a random. So that's very important. Then what is the meaning of that? So already we have seen that this is a random string because they are generated from a random event of coin tossing. But it was XORed with some secret message which had some probability distribution. But what just now we have proved that if you are doing a bitwise XOR, then if this is random, that means if this is random, then the output will also be random. That means that will also become a random string. Now you can understand that from here, from a random string, you cannot get any extra information. For example, suppose the girl wants to get some information about the secret. Note that the girl has already this as a share. So she knows the last bit of the share is 1. Now she wants to guess this, what should be the last bit of the secret. Now you can understand that she gets this last bit because the head and tail, it came as head. Now when he gives him 1, that means head, then what is the relation that he has with this last bit 0? That means it is the outcome of a coin toss and there was no relation with the secret except for the fact that both of them are 6 bit long. Okay. Suppose all of the participants or outsiders, they also know that the password is 6 bit long. Then she also knows that the password is 6 bit long. Everybody knows that the password is in binary. So she also knows the password is binary. Now, since the last bit is an outcome of a head and tail and there is no relation between this secret, as a result, the probability of guessing the last bit having this at her disposal, the probability of guessing it, the last bit is exactly half, because she does not have any extra idea that what could be the last bit. So she can guess with half probability that the last bit would be half. Similarly, if you consider yourself, you do not have any extra share, any share, you do not have either this or this. You only know that the password is in binary and the length of the password is 6. Now, if I ask you that what could be the probability of last bit to be 0, you will suddenly with probability half, you will also be able to say that the last bit is 0 is with probability half. Same as this girl. That means for this girl, the probability of guessing for the girl, the probability of guessing the whole secret correctly is exactly half to the power 6. Now you, the outsider, you do not have any share. The probability of guessing the whole secret correctly for you is also half to the power 6. And just now we have proved this is also become a random string. As a result, from here, the probability of guessing it correctly is also half to the power 6. For the boy, the probability of guessing it correctly is also half to the power 6. So you can understand that these two guys, the boy and the girl, they have the share. Even if they have the shares with them, the probability of guessing the secret is half to the power 6, same as you who do not have any of the shares. That means even if they have the shares, the probability of getting it correctly is half to the power 6, same as you who does not even have any share. That means with that share, this boy and the girl will not have any extra privilege over this outsider, over you. That's why this kind of schemes are known as perfectly secure secret sharing scheme. So in short, we call it SSS, perfectly secure SSS, secret sharing scheme. Is the idea clear to all of you? Any question till now? So you can understand that if both of them they join, they will get back the secret, but from one secret they will have no extra privilege over outsider who does not even have any share with him or her. So any question till now? Okay, so I hope you understood it. Okay, let's then come to the question that how can we extend this idea to, so it's only a 2-2 scheme. So how can I extend it to 2n scheme or maybe kn scheme? That means say there are say 6 participants or 4 participants and say the threshold value is 3. Then how do you extend it? So that's a natural question that comes to our mind. So let us now try to extend the whole idea. Okay. To do so, let us have a very simple geometric concept. Suppose I consider this as an xy plane. Say this is my xy plane. Okay, so this is my two-dimensional x and y. Suppose I have given you a single point. Okay, and I ask you the question that how many straight line that you can draw, that each of them that passes through this point. What would be your answer? How many straight lines that you can draw that passes through this point? How many? Anybody?
Infinite.
Infinitely many straight lines. So there exists infinitely many straight lines which passes through this point. Okay. Now if I ask you the same question but just increased one extra point. So instead of having only 2 points, 1 point, now I have 2 points on the same xy plane. So initially I had only 1 point, now I have 2 points. And if I ask you the question, how many straight lines that you can draw that passes through both the points, what would be your answer? That should
Exactly one.
exactly 1. So there exists exactly 1 straight line. So I'm very sorry that it's not, maybe I can draw through this. Yeah. Okay. Oh. Yeah. Oh, anyway. So it almost looks like. So now you can see that from infinity, it comes into exactly 1. So from infinity, it becomes unique. And that too, just by adding by 1 extra point. So that's a very important observation that Adi Shamir did. So you remember RSA crypto system? So Rivesh, this man was Shamir, Adi Shamir. And he also invented another very interesting idea of secret sharing. Okay, so let us try to explain the whole thing. Okay, so this the equation of this straight line must be of this form: y equal to mx plus c. That means this is an 1 degree curve. So for 1 degree curve, you require 2 points, at least 2 points on that curve. So suppose you have only these 2 points, then you can certainly uniquely determine the equation of the straight line. On the other hand, if you have only this straight line, then you can certainly determine these 2 points. That means what I am trying to say, that only 2 points on the curve is sufficient to uniquely get back this curve. That means if you have only these 2 points on that curve, then you may forget about the curve, because the curve can be generated automatically by using these 2 points uniquely. Okay. Similarly, in case of a curve of this 2 degree curve, so you understand that a 2 degree curve must be of the type parallel, this type, parabola type. So this is y equal to, say, okay, so whatever may be this equation, so some y equal to 4 or maybe ax square plus b form. Okay. So this will look like some parabola. So in case of parabola, so this is a 2 degree curve, 2 degree curve. And in case of a 2 degree curve, you can understand that 3 points on the curve are sufficient to get back the curve uniquely. That means if you just remove the curve and if you have only these 3 points, then you can uniquely get back this curve. So for 2 degree curve, 3 points are sufficient to get back the curve. So again, if you recap, for 1 degree, 2 points are sufficient. 2 points on that curve are sufficient to get back the curve uniquely. For 2 degree curve, 3 points on that curve are sufficient to get back. That means if you are only given these 3 points, then you can suddenly uniquely get back this curve. So in general, if you have a polynomial of degree, say k or k minus 1, say a0 plus a1x plus a k minus 1 x to the power k minus 1. So it's a k minus 1 degree, k minus 1 degree polynomial. Then how many points on the curve will be required? Any guess? How many points?
A point.
K points. So you can understand that at least k points will be sufficient. Here at least 3 points on the curve. You could have more points, right? That will also give you the idea. But at least 3 points are required to get the curve uniquely back. So that motivated Adi Shamir to construct a scheme. Okay, so let us have a look at the scheme. Maybe I can write it here. Okay. So idea again is, suppose x-axis and y-axis is there. Okay, and suppose they want to construct, say, a 3-4 scheme, 3-4 secret sharing scheme. Okay, that means there are 4 participants, and if at least 3 of them they agree to get back the secret, they will be able to get back the secret. Okay, suppose the secret is k equal to 1. Okay, so the number of participant here, w is 4, w is 4, t is 3, and this is my secret. That means if at least 3 of the participants will join and they do some calculation, they will be able to get the value of k to be 1. Okay, but if 2 or one participant will come to calculate the value of k, they will not be able to do so. So that is the idea. Okay. So what the dealer will do, the dealer will first construct a polynomial fx of, so since this is 3, 4, so the dealer will construct a polynomial with degree 2 such that the secret will be the constant term plus say a1x plus a2x square. Okay. See, this is the constant term is nothing but the secret. That means what is the value of f0? The value of f0 will be 1. That means the secret. So suppose this is my 1. f0 is 1. So since this is a 2 degree, so this values are chosen randomly. A0 and A1 are chosen randomly chosen. Okay. So you can understand that this may look like in general form, this will look like a parabola which passes through this point. Suppose this is my parabola. Okay. So this is the secret. So the dealer has, the first step is the dealer must choose a polynomial of degree 2 or at most 2. I must say at most 2. Such that that polynomial must pass through this point, the secret. Secret is my k equal to 1, that must pass through this point. Now, so suppose this is my 1, so this is my 2, this is my say 3, this is my say 4. Okay. So that this point is nothing but 1 comma f of 1. This point is 2 comma f of 2. This point is 3 comma f of 3, and this point is say 4 comma f of 4, right? Okay. For the sake of simplicity, suppose I have taken a1 say 1 plus say 2x plus 3x square. So suppose I have chosen this to be randomly like this. Okay. Now each of these participants, so there are 4 participants, each of these participants are given this as the share, this point as the share. That means participant 1 will be given the share as 1 comma f of 1. Can anybody tell me quickly what is the f of 1? F of 1 is how much?
6.
6. For second participant, it will be 2 comma f of 2. What is this value of f of 2? 2 comma quickly
19.
19. Okay. So third participant will get 3 comma f of 3 quickly
34.
okay, and the fourth participant will get 4 comma f of 4. How much is that?
57.
How much?
57.
57. Okay, good. So all the participants will have this as their shares. So they are the shares. Now, any idea how to get back the secret? Any 3. Just now I have defined for 2 degree polynomial, how many points are required on the curve for 2 degree polynomial? For 2 degree polynomial, 3 points are required, right? For 2 degree curve. So it was a 2 degree curve, and when any 2 of them, any 3 of them, they will come. Okay. So suppose 3 of them, suppose this, this, and this, they come together. What they will do? They will simply solve the equation. So they know that the dealer has chosen a 2-degree polynomial because they know that it is a 3-4 scheme. So for 3, the dealer must choose a kind of 2-degree, at most 2-degree polynomial. So they know the dealer must have chosen a polynomial of this form: a0 plus a1x plus a2x square. Note that they do not have any idea about this value. So what they want to find, they actually want to find this value, right? So they want to find this value because that is the secret. So they assume that the dealer has chosen this, so they want to find this value. Now, what are the information they have? They know that h of 1 is suddenly, suppose these 3 guys, they came together to compute the secret value. Suppose these 3 values, okay? So
Sir,
what they
for
do,
F2 it will be 2,70.
which one? S?
F2, 2, F2,
Yes, how much?
2,70.
17, 17.
Yes, sir.
17, sir. 17.
Okay. So you need to be little careful while calculating this. Other values are same. Is it correct? Other values? Please check. Otherwise, it would be difficult to get back. Okay. If
Yes.
calculation is okay. So h of 1, what is h of 1? H of 1 must be this value 6. What is h of 1? H of 1 is the evaluation of the polynomial at this point. So they do not know the polynomial, but they know the value of h of 1 is 6 because the first participant is there. So these 3 participants, they come together to open the secret. How they are going to do that? So they are now going to solve a system of linear equations. So h of 1, this value is 6, is same as a0 plus a1 into 1 plus a2 into 1 square, right? Now, what is the value of h2? The value of h2 is 17. The second participant knows this value, okay? So a0 plus a1 2 plus a2 2 square. Third participant, he also joins to open. He knows h of 3 value, and that is 34. a0 plus a1 into 3 plus a2 into 3 square. Now you see that there are 3 equations. So you can write it in this way. There are 3 equations in a0, a1, a2. And there are 3 variables. So there might be a chance that this system of linear equation, you can solve it. Okay, so if you write it properly, then you can write it in this way, in a matrix form. So a0, sorry, not a, 1, 1, 1 square, 1, 2, 2 square, 1, 3, 3 square into a0, a1, a2 equal to 6, 17, 34. You can write it like this. If you multiply this, so how do you multiply a0 plus a1 plus 1 square into a2? That is the same thing, equal to 6. Similarly, multiply this with this, equal to 17. Multiply this with this, equal to 34. So this equations, this system of linear equation could be written in terms of matrices. Now this is a 3 by 3 matrix, and if the determinant is non-zero, if this determinant value of this matrix is non-zero, then suddenly you will have the inverse of it, and if you multiply both sides with this inverse, then suddenly you will get this value. That means this system of linear equation will be consistent if and only if this determinant value is non-zero. Okay. Now you see that this is a special form of a matrix, and this form of matrix is known as Vandermonde matrix. Vandermonde matrix. And you know that how to calculate this determinant value. So if this is your A, then date A is nothing but, you can calculate very easily, 1 minus 2 into 2 minus 3 into 3 minus 1. And so you can see that this is certainly not equal to 0. As a result, always this kind of matrix will have determinant value non-zero. As a result, the inverse of this matrix will always exist. As a result, this system of linear equation is always consistent, and as a result, you will certainly find the value of A0. Now, if you solve it, for example, if you solve it just simple Gaussian elimination method or by whatever means, for example, suppose this is A0 plus A1 plus A2 equal to 6, then A0 plus 2, A1 plus 4, A2 equal to 17, then A0 plus 3, A1 plus 9, A2 equal to 34. If you solve this and try to find the value of A0, can you please quickly solve it by any method? Just solve it. For example, just from, say, if I have 1, 2, 3, then if I have, say, 1, say 2 minus 1, equation 2 minus 1, that will give you, so A1 plus 3A2 equal to how much? This will give you 11. Similarly, if you have 3 minus 2, that will give you A1 plus 5A2 equal to 34. Now, if you subtract this from here, say this is 4 and this is 5, if you subtract from there, you will get, say, A, so that will be,
So not 34, 17.
oh yeah, it will be 17, right. And if you subtract from here, you will get, so minus 2A2 equal to how much? Minus 6. So A2 equal to 3. Now you see that A2 was already 3 in my secret polynomial. In my secret polynomial, A2 was already 3. A2 was already my 3. So that you can solve it uniquely. Similarly, you can also find the value of A1. The main target is to find the value of A0. So now you can understand that if you put this value of A3 in these two equations, then it will have this. And then after solving that, you will find finally A0. And that value will certainly be 1. And then you will able to uniquely calculate the value of A0 uniquely. And that will be your basic idea of the scheme. Now the question is, what will happen if, is it clear to all of you how to get this 3 or more? If 3 of them they will able to come, then you can understand that if 4 of them will come, you just take any 3 equations that will give you the unique solution. And you will get back the value of A0. The same thing would happen if it could be, suppose instead of these 3 participants, if you can check on your own, if what will happen if they will come. Instead of the first 3, if the last 3 will join, then you can understand that the same thing, they will do not know, they will just guess this, the polynomial value of this. So instead of having this equation, you will have basically the extra, the fourth equation, H4 equal to something 57 equal to A0 plus A1 into 4 plus A2 into 4 square. In that case, you will have to consider this 3 equation, and still you will able to get, just now we have defined, because this is an equation of a parabola, and any 3 points on that parabola, any 3 points, in that case you will have this one, and this one. Any 3 points on the parabola will uniquely give you back this curve, and when you will trace back to this curve, you will certainly find the curve will cut the y-axis at a unique point, and that will be your secret. So it was at 0, right? So if you draw with these 3 points, you will again get the same parabola, and that unique parabola will cut the y-axis at a very particular point, and that will be your secret. Clear? So geometrically, it is also very easy to understand. Now the question is, what will happen if you have 2 points on the curve? Just like in case of a 1-degree curve, if you had 2 points and if you drop one of them, so from 2 points you have a unique straight line. But if you drop one of them, then what will happen? There will be infinitely many curves which passes through this point. So there will be infinitely many points which will cut the y-axis. So for one participant, he will not be able to guess where it is the secret, because it will cut the y-axis at infinitely many points. Similarly, in case of a parabola, if you had, suppose, only 2 points, instead of 3 points, you had only 2 points, then you can understand that this will curve the y-axis at infinitely many points. You may not be able to guess which one is your secret, because at each of this point you will have to think that that is my secret, but these options will be infinitely many. So you will not be able to guess exactly where it will cut at the y-axis. But if you just increase one more point, that will uniquely give you a curve back, and that curve will certainly uniquely cut the y-axis, and that could be your secret. So that's the idea of Shamir's secret sharing in a very intuitive way. Is it clear to all of you? Any question till now? Any question till
Sir,
now?
what happened in this picture?
In that case, suppose two, say first participant and second participant, they come. So they have only this 2 points, this point and this point. Okay. So now they are going to draw a curve, but that curve will, they will not be able to determine the curve uniquely, right? What does it mean? That curve will cut then the y-axis at infinitely many points. There will be infinitely many curves which passes through this point, because that is not a 1-degree curve then. It was a 2-degree curve. 2-degree curve which passes to this point, and there exists infinitely many such points. As a result, there will be infinitely many cuts on the y-axis. So when two of them, they will come and they will try to guess what was the secret, then they will find that by using this method, they will find that there are infinitely many points on the curve on which the curve meets the y-axis. That means each of these points will be a possible secret. So he will not be able to guess, or he will not be in a position to find exact value of the secret. Is it clear? Because it's a 2-degree curve, but so it is at most 2-degree curve, because you are actually choosing these points randomly. So it may happen that while choosing this point, this may be 0. If this is 0, then it will be a 2-degree point. But the dealer knows that this is a, then it will be a 1-degree curve. But for participant, they will also, they always have to guess that that will be of this form, because they do not know that A0 or A2 is 0. Okay, because they know only the coordinates, nothing else. That's why for them it will be a blank. But for dealer, by chance, if it comes to be a 0, then it will be a 1-degree curve, fine. But these guys will not be have any clue that this becomes always 0, or they will not be able to guess whether this is 0 or not. They will have to think in a 2-degree curve form. So they will have to consider the 3 equations and so. So if you have, so simple, the idea behind is that if you have, say, 3 variables are there, say A0, A1, A2. Okay, and suppose 2 of them, they will come, then what they will able to do, say first and second participants come, then they will know F1 and they will know F2. That means they are able to construct only 2 equations, right? Not the 3 equations equal to A0 plus A1 2 plus A2 2 square. So there are 3 variables in 2 equations. So you can understand that there will be infinitely many solutions from A0, A1, A2. So each of the solution could be a secret. So they will get infinitely many solutions. Is the idea clear? Any question, any doubt? Please let me know. Any
Sir,
question? Yeah.
replace 3 by 100 and 4 by 101, suppose. Then what should happen? What?
Sorry. Here
In
in
this
this
threshold,
in this
in this
in this
case,
in this
in this
equation,
case. No, 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 no.
then
T is equal to 100, W is equal to 101.
okay. So you
Um,
want to construct a 100 101 secret sharing scheme, right?
yes, sir.
Okay. In that case also the dealer will choose in that way. So for a secret sharing scheme there must be some secret. So what is your secret? Tell me some secret, some value.
Suppose K is equal to 1.
Okay, so secret is my 1. So the dealer will choose, so A0 is always his secret. So 1 plus, so A1 x plus dot dot A k minus 1. So here k is 100, that means 99 x to the power 99. Where this one, A1, A2, A99 will be randomly chosen. So they are randomly chosen. Randomly chosen. So the dealer will consider this. So when the dealer, so look at this is done by the dealer, right? So he will first choose these values randomly. Suppose A1 value is say 1.5, A2 value is say 9.97. Say this value is say 1.11117. Okay, and so on. So he has chosen 99 random values. Then he will construct this polynomial fx equal to secret is always a0, 1 plus 1.5 into x plus say 9.97 x square plus and so on plus 1.1117 x to the power 99. So this is a 99-degree equation. So 100 points are required to get back this curve uniquely. And you are here, you require 100 value as t. So you have 100 points on the curve. Suppose the curve looks like this. Okay. So 100 points, you just plot it like this. So this is 1, say this is 2, this is 3, and say this is 90, 100. Say this is 99. And your secret value is 1. So this is say my 1. So this is 0, this value is 0, 1 position, this point. Okay. So evaluate the polynomial at 1, whatever you get, say you get f of 1, say you get, that will be a value, say you get 973.6789 something, you get this. So this coordinate will be 1 comma this value 973.6798. So this will be given to the first participant. Similarly, this will be given to the second participant and so on. So when 100 of them will join, so this is 101. So starting, so this is also say this is 100 and this is 101. So there is also value of f101. So all the values, so each of the point will be given as a share to each of the participant. So 101 participant will be given, each of them will be given a single point. That means this, a coordinate. And if 100 of them will come, they will suddenly get back the curve uniquely, because for 100, for 99-degree curve, 100 points are sufficient. So when 100 of them they will join, they will get back the curve uniquely, and that curve will suddenly cut the y-axis at the unique point, and that unique point will be your secret. Okay. Or if you think it not geometrically but analytically, then you just need to solve an 100 by 100 matrix, and from that matrix you just find the value of A0, and that will be your secret.
But calculating that inverse must be difficult.
Yes. So calculating inverse, if you look at the algorithm for finding inverse, then if you find that if it is an n cross n matrix, then the finding inverse, the order is around n square, n cube, assuming that the addition and multiplication, they are of the same complexity unit 1. So basically you need to calculate in order of n cube some addition and multiplication. By using that, you can do that, and there are few efficient multiplication algorithms are there whose order is around in 2.7 or something. I exactly forget this exact complexity of this. So it is really little less than 3. Okay, so that you can use to have some multiplication for better approximation. But it's really true that it's finding inverse may be difficult job, but for 100 by 100 it's not that difficult. Or you can use Gauss elimination method, that also takes order n cube size for complexity. So by using Gauss elimination method, you can also have the inverse of this. So your basic idea is to not finding the inverse. Your basic idea is to solve this to get the value of A0. So you can use Gauss elimination method to find this value of A0. That can also be done in order n cube size. That means if you have n variables, then it takes order n cube to solve this. Is the idea clear to all of you?
স্যার A0 কে কেন আমরা সিক্রেট বলছি? পুরো পলিনোমিয়ালটাই তো সিক্রেট।
Yes, the whole polynomial is secret, but the point is, it's a very good observation. The point is, in case of Shamir secret sharing, though A0 is the secret, it actually reveals the whole polynomial, which was also a secret. And in my class, I will mention this kind of application in image encryption, image secret sharing. So for image secret sharing, I will explain. But that will, if you consider all of them as your secret, then how that concept can be used for image secret sharing. I will come to it later on. But your observation is perfectly correct that the whole polynomial is secret, and the qualified set of participants, that means if the value number of participants is more than t, they will able to get the whole polynomial, even though it is sufficient for them to calculate A0. But there is no better algorithm to calculate only A0 very quickly without revealing the values of A1, A2, and AK minus 1, and so on. So one may think about this, that how can you find the value of A0 without calculating the values of A2, A3, and so on. But it has been found that to calculate A0, you also need to find these other values, because it actually some elimination methods. So for that, other coefficients are automatically done. So that's why, and this concept will be used for secret image secret sharing scheme. I will come to it later on. But till now, is it clear to all of you, the concept? It's very interesting concept, very simple, but very interesting. But is it clear to all of you till now?
Yes, sir.
Yes, sir.
Okay. Now the point is, how do you implement this? You can understand that this A0 value could be even root 2. Okay. Say A1 may be root 19, because any real number. So you can understand that if you make a kind of approximation of this, for example, root 2, some value, 1 point something, if you take this and if you replace in the equation, then that may not give you the exact value of A to be root 2, because some question of precision will come. And it is really difficult for computers to really deal with root 2, root 7, root 19 kind of numbers, because you might have taken a degree of precision maybe say after point you might have taken 10 digits. Somebody might have taken 20 digits. Somebody might have taken 100 digits. So those who will take 100 digits, they will have less error than you. So the question is, how can I implement it properly? And here the concept of finite field comes into play. Okay. So the whole story, but rewritten in a different fashion and very simple way. Okay. So again, if you just recap the whole story, so what was your idea? You want to construct some, say, KN scheme, KN secret sharing scheme, or say maybe TW secret sharing scheme, TW secret sharing scheme with your secret value K, right? Okay. So three parameters will be given: T, W, and the secret value K. Okay. Suppose all of them are in integer. So of course, the number of participants cannot be in fraction. Whatever be the secret could be in fraction, but assume that all of them are integer. Say there could be a maximum of this. So max of this T, W, K, right? So choose a prime P, prime number P, which is strictly greater than max value of T, W, K. Note that T is always less than W, less than equal to W. So you may just ignore this. So choose a prime P which is greater than the maximum of W and K. For example, for 3-4 scheme, secret sharing scheme, your secret could be 10, right? So it is more than the value of W. In my previous example, the value of K was 1, that is less than 4, that means less than W. So it might happen that the value of secret is greater than the number of participants. So choose a prime P which is more than the maximum of this value. So consider ZP. And believe me, all the theory that just now I have explained are also satisfied here. That means the dealer will choose. So if this is W, the dealer will choose a polynomial fx of degree at most W minus 1 with coefficients from, in my previous example or in my, when I just gave you the intuitive idea, it was on real line. Now I am giving you, instead of real line, I am now considering over ZP with coefficients from ZP. What does it mean? Suppose in my previous example, if I consider my previous example 3-4 secret sharing scheme with, say, K equal to 1, then the dealer will choose a prime P. So if he chooses P to be 5, then it is sufficient because 5 is greater than 4 as well as 1. Okay. So he will choose, say, prime P. Now he chooses a polynomial of degree W minus 1. W minus, sorry, not W minus 1, degree should be T minus 1. Threshold value minus 1. So he will choose a degree of at most 2. So he may choose like this, fx equal to, the secret could be the first one. So this is my class 1 is my secret, plus, say, randomly he chooses, say, class 2 into x square plus class 3 in, sorry, class 2 into x plus class 3 into x square modulo 5. See, all the coefficients are coming from Z5, right? So it's not required. If I put it like this class notation, then it's not required. So what I want to mean is that all the coefficients of this, so this will be square. All the coefficients are coming from ZP, Z5, right? So this is a polynomial of degree at most 2. So T minus 1, T was my 3, degree 2. where I have chosen, the dealer has chosen these values randomly. And then again the same story. Again the same story. If you consider this, then what is my F1? My F1 value is, what is my F1? 1 plus 1 plus 1, class 6. That means class 6. That is again class 1. What is my F2? F2 is, quickly tell me, F2 was
Class 2.
17. That means class 2. Class 2. F3 was how much?
34.
34, class 4. And F4 was 57 or something. It was how much?
57.
57. That means class 2. Right? So each of the participants will be given 1, 1 or class 1, 2, class 2, 3, class 4, 4, class 2. Okay. Now when each of them will join, I mean, if qualified number of participants, for example, if 1, 2, 3, they will join, they will not exactly, they have only these 3 points, nothing else. But they know that it is a 3-4 scheme. That's why the dealer must have chosen a at most 2-degree polynomial. So they will assume that the polynomial must be of this form, plus a2x square, but they are now classes. They know that this value of p is also public. They know that everything is in modulo 5. If this will come, then they will put h of 1, and this value is class 1, and that is same as class a0 plus class a1 x plus a2 x square. X square here is 1. This is also 1 square. Okay, this is my 1 class. Similarly, h of 2, h of 3, and same van der Monde matrix will also be here. So you can write it in this way: 1, class 1, class 1, class 1 whole square, class 1, class 2 whole square, class 1, class 3 whole square, into a0, a1, a2, and the right hand side will be 1, 2, and 4. Class 1, class 2, class 4. And again, the same thing. This is a van der Monde matrix. The equation, the determinant value will be non-zero, because this will be class 1 minus class 2 into class 2 minus class 3 into class 3 minus class 1. You can check that this value is always not equal to 0 in Z5. Okay, because they are all, each of them are non-zero element, and the product of non-zero element will always be non-zero in the field. That's why this determinant value is always non-zero. As a result, you will have the inverse of this, and this equation will have a unique solution. As a result, you will always find this a0, a1, a2, and so on. If you get a0, then you are done. Basically, you get the secret. Now, if 2 of them will come, you can understand only 2 equations with 3 unknowns. And how many solutions will be there? You can understand that the number of solutions. Suppose this and this will join. Okay, so only these 2 equations are there. H2 equal to class 2 equal to a0 plus a1 class 2 plus a2 class 2 whole square. Only these 2 equations are there, and 3 variables are there. Now you can understand that you have to guess one of the variables. Suppose you have to guess this one. And how many options are there for it? It could be anything from 0 to 4. 0, 1, 2, 3, 4. Because this will be a coefficient coming from Z5. So what could be its values? It could be either 0, 1, 2, 3, and 4. So the number of choices to get a solution here is basically you have to guess it 5 times to get it correctly. Now think about yourself. You suppose do not have any share, none of these shares are with you. You only know this is a 3-4 scheme, 3-4 secret sharing scheme, and everything is done modulo 5. And I ask you, what is the secret value, A0? You know that secret value could be any one of the values from this set. That means from either 0, 1, 2, 3, or 4. So with probability 1 by 5, you will able to guess it correctly, A0. Now think about these two guys, only these two guys. They have to guess. There are 3 variables are there with 2 equations. That means one coefficient they have to guess. And this coefficient value will come from Z5. And this coefficient could be anything from 0 to 4. That means for these two guys also, even if they have 2 shares, the probability of guessing it correctly will be exactly 1 by 5. The same as you, who is the outsider who does not even have any share with him or her. That is why it is also a perfectly secure secret sharing scheme. Is the idea clear? Clear? Now you can implement it quite easily, the secret sharing scheme. Is any question? Do you have any question till now? Any question?
Sir, why 1 by 5? Can you please explain?
Okay. Yes. So first think about first and second participant. First plus 2. Okay. Only these two guys, they came. Remember that this was a 3-4 scheme. So first and second participant, they are not qualified to get the secret k equal to 1, right? Now, when they will come, how many equations that they are going to have? For 1, they know that f1 value is something and f2 value is something. This they know. They know that this value is 1 and this value was 2, something like that. Okay. And they started with this equation, a2 1 square. Similarly, they just put the value of 2 here, a0 plus a1 2 plus a2 2 square. Okay. Just if I write it like this, then this will be a0 plus, I am not writing class. Okay. Just assume that class is there. So a2 equal to class 1 means 1 and a0 plus 2a1 plus 4a2 equal to class 2. Okay. Now try to solve this equation in Z5. Similar way, like if you just subtract from here to here, say this is my 1 and this is my 2, say subtract 2 minus 1, what you will get? You will just, this will be out. So this will be a1 and plus 3a2 equal to 1. That means class 1. Okay. Now you do not have any other equation, only these two they came. Now you have to guess that, okay, what could be the value of a1 or a2? Only one equation and 2 variables. So this is my equation 3 and I have 2 variables, one equation and 2 variables. Then what to do? You need to guess some of them. Suppose you want to guess this one, a1 value. Now how many options for a1? You have 5 options. Okay. For each of this option, you have the value of a2. Suppose you assume that a1 is 0. Then what is the value of that? Will imply a2 value is
1/3.
1/3. That means 3 inverse. Remember, we are now in Z5. What is 3 inverse in Z5? Quickly, anybody? 3 inverse in Z5?
2.
Okay. So if a0 equal to 0, then a2 equal to 2, and in that case, a1 will be your, a0 will be your how much? From here you will be able to calculate. So in that case, a0 will be your 1 minus a1 minus a2. So this minus mean 1 plus 4a1 plus 4a2. So a1 value is 0 and a2 value is 2. So a1 1 plus 8. That means 9. That means 4. In that case, A0 will be 4. See, A0 is not certainly 4. But if A1, if you guess A1 equal to 1, then you will get some value. Similarly, when you will able to guess A1 to be correctly, then only you will get A0 equal to 1. So you see that there are 5 options. So for each of these 5 options, you will get each of the values of A0. So for A0 also you will get 5 different options. So it is for these two guys. When first participant and second participant, they will come. Now suppose yourself, you do not have any share. You have only the information that this is a 3/4 secret sharing scheme and everything is done modulo 5. Now I ask you, what is the value of A0 or the secret K? You know that the K value will suddenly come from here, one of the values from ZP, Z5. Now how many options that you have? Exactly 5 options, because you know it could be either 0 or 1 or 2 or 3 or 4. 5 options. And for these two guys also, they also have 5 different options. So having shares with them, 2 shares with them, the information that they will have about the secret is same as you, who does not even have any share. That's why this scheme is known as perfectly secure secret sharing scheme. Is it clear now?
Yes, sir.
Okay, any question? Anybody? If you have any question, please do not hesitate.
Sir, during implementation, what should be the value of P then?
Yes, now the point is how to implement it. That's an interesting question. Okay, so
আমার একটা কোশ্চেন আছে
yes, please.
স্যার। বলছি পলিনোমিয়ালটা রিয়েল ফিল্ডের থেকে যখন আপনি ফাইনাইট ফিল্ডে নিয়ে আসলেন, তো ডিফারেন্সটা কি আসলো?
Mathematically, there is no difference. Now the difference will come in implementation viewpoint. Okay, so suppose you have fx equal to, say your secret is √2 plus, say, √9x plus, say, √7x plus, say, √11x square. So what is the value of f1? Can you be able to tell me what is the value of f1? This is √2 plus √7 plus √11. Now what is this value? So to first participant, you are going to give this value, 1 comma this value, and how to calculate this value? That is the point for computers. For computer, it may give you some approximate value of this. Suppose this value is, say, 3 to 5, around 6 point something, say around 6.9786 something, say up to 10 decimal places you have taken, and somebody might have taken the same thing with, say, 100 decimal places. So both of you are doing some approximation, both of them are approximation, but this is better approximation. But the point will be, when you are going to solve this equation by putting this value f1, you are giving some approximated value. As a result, when you will get the value of A0, that will also be an approximated value, and that will never be represented by √2. So you will not get back √2, which was your actual secret. As a result, some confusion will come. So you cannot deal with the real numbers because of implementation issues.
Sir?
But yes.
Here, √2 is the key.
Yes, √2 is the key. So the basic point would be how to implement it. To implement it, fortunately, the same calculation, algebraic calculation, also holds in ZP. So for implementation issues, you will have 2 algorithms. One algorithm will be the share generation algorithm, share gen algorithm. Another algorithm will be your secret reconstruction algorithm. Reconstruction algorithm. In case of share generation algorithm, you have to give 3 inputs. One is T, the threshold value, W, the number of participants, and the prime number P, on which should be greater than, okay, there should be another, the secret K. Okay. So this p value should be strictly greater than this w and t value. So this value should be strictly greater than.
Okay, since we are going to work with characters, we have to give a p-value that is greater than 255.
No, that depends. You can do that, but that depends actually if you are doing in case of, I mean, you can make it even smaller, like 8-bit characters, then you can make
That
it
would be
maybe 1
255.
block, maybe 4 block, you can do that. And in case of 4 block,
But
you can make it. It's up to you. So you can even do it for more than 256, but if you give it more than 256, then the problem will be when you will get back the secret or the shares, not the secret, when you will get the secrets, you may not have a character representation. Suppose you have taken
yeah,
some,
that happens.
yeah, that happens. So if you consider whatever you will give the number instead of character. If the shares could be in the form of numbers, then it's fine, then it is not a problem, then you can take anything. It depends on your implementation issues or how you want to represent it, nothing else.
So, in case I don't have the actual shares, in that
Yes,
case, even if I generate any character which is not mappable, that is okay,
yes, yeah,
right? If I use
yeah,
255 plus prime number, then it
yeah,
will only work when I have all the primes and I'll get back the original character. Because
yes,
I'm not giving any character that is unmappable.
yeah.
Okay, then okay. Sir. Because sir, if I break one character into 4 bits, no, sir, it will be more difficult to reconstruct him into
Yes.
single 8 bit.
So instead giving as a character back as a shared, that's what I am saying. So this is share generation. So it will generate W many shares, right? W many shares. For one key, it will generate W many shares because W was the number of participants. So each participant should have some share. So this is say share 1, share 2, share 3, and dot dot share W. So W many shares. Now, if you consider this to be as an integer, like which is less than p, then everything for this k, you will ultimately get some number for this share. For this k, you will get some number which is also strictly less than p, because everything is done modulo p. So at the end of the day, for each of the share, that will be less than p. For example, if you look at this, in case of this, it was, in case of this, it was like this. F1, it was ultimately 6, but since we are dealing with modulo 5, it becomes 1. So the first share here, so here if we consider the same example here my t was my 3, w was my 4, p was my 5, and for k it was my 1. For the first share, it gives me initially the value was 6, but since we are dealing with modulo 5, it gives me back 1. So which is strictly less than p equal to 5. For share 2, it was 17. As a result, it gives me 2. For third one, it was how much? It was
34. 34.
34.
57.
So it gives me 4. And the fourth one, whatever may be, and the fourth one, it was like 57. So it gave me 2. Okay, so see, they are the shares for k equal to 1. For k equal to 1, I am getting 1. For the first participant, I am getting 1, 1. For the second participant, I am getting 1, 2. For the third participant, I am getting 2, 2. For the third participant, I am getting 3, 4. For the fourth participant, I am getting 4, 2. So 1, 2, 4, and 2, they are classes actually. So you need to just, it's a notation I have used. So this algorithm generates the share, and each of the shares should be a coordinate system. So 1, something, 2, something, 3, 4, comma. So these values are basically the function evaluated at that point, which is the ID of maybe a participant. So 4 participants are there, participant 1, participant 2, 3 and 4. So ID of each participant will be the ith ID of the ith participant is I. So for that you are getting this value. Is it clear now? So you may not think about in terms of characters, but you can think of in terms of a number. So you may start with some character, for example, A, B, C. You can convert it into say, so 65, 66, 67.
Sir, the range for lower cases ranges from 97 to 122. So P
Yeah.
must be greater than that.
P must be greater than that. Yeah.
But in that case also I'll get some characters like for shares that would be below say 65 or something that is not mappable. Then also I'll get some characters which are unmappable. So it's better,
Yes.
no sir, if I take a prime that is more than 255 so that I can make it more difficult for the attacker.
It depends, because you can understand that in this system, the attacker has no other alternative except for doing the exhaustive search. So that mathematically you have already proved.
Yeah, so the length of the size of the field, the longer the size of the field, the more complex it's for the attacker.
Yeah, sure. But at the same time, it will be more complex for the share generation algorithm as well, right? So that would be a kind of trade-off, that you need how much security and how much computation power that you have. If you have more computation power, you are welcome to deal with longer or bigger primes. Okay, is it clear to all of you how to implement this?
The key is always 1.
No. Key is whatever you like. So first choose T, W and key. Depending on these values, choose P. K could be anything. If K is always 1, then what is the meaning of this scheme? Nothing. So you can choose whatever may be the value of key and then choose P accordingly. The P value should be more than K and W. That's all. So what, for the simple understanding, first try to implement with some integer. Okay, first take T, W, P and K. Then depending on this P, it will generate this. Okay, so they are the shares. Now the share reconstruction, secret reconstruction one will take as input the shares. So here you need to put how many shares you want to incorporate. Say somebody says I want to incorporate with 2 shares. Then it will request him to insert 2 shares. Say he has given 1, 1, 1, 1, 1 and 1, say 2, 2. Then what he will do, it will do this mathematical things like solving the system of linear equation. And then whatever it will be able to solve, it will return it as a secret. It will give you for it will be able it solve it. It will say that insufficient data, so I am unable to solve it uniquely. Then it will ask for another data. But if you put 3 of them, like the third share, like 3 and 4, if you give them, then it will take 3 points and then it will solve and it will give you back the value of K correctly. So first try with only one secret, not with character or anything else. First try to solve it, but your aim will be you must have some secret like in characters or maybe whatever, maybe an image, and then use this concept to do the remaining part. Is the idea clear? Any question till now?
Sir, in case of image also the prime will be greater than 255 because the intensity is 0 to 255.
Yes, if it is more than 255, then that could be a problem. So usually for most of the cases, it is taken as 251. Okay, so I'll come to it just now. But is the idea clear?
Yes, sir.
Okay. So I'm going to show you an attack. This attack, okay, I'm not going to show you that attack. Then maybe I'll directly come to the image encryption. So suppose I have an image, say this is an say black and white image. So in image, if you look at this image, there are of many different formats. For example, this may be black and white image, which is basically purely black or purely white. This may be grayscale image, or this could be color image. Okay. So depending on the nature of the image, black and white image means if you zoom this image, then ultimately you will find that all the images are basically going bigger and bigger, and ultimately it will ends up with few of the boxes. Either that box may be complete black or complete white in case of a binary image. In case of grayscale image, these boxes may be of different shades. For example, suppose this is more black, and suppose this is little less black, and say this is completely black. That means you are basically having a different shades. So in case of black and white, the value of pixels is either 0 or 1. In case of gray images, this blackness is actually distributed over 0 to 255. That means, for example, suppose this is white, then this value is 0, and say this is complete black. This value is 255. And in between this value, for example, suppose this is compared to this, it is less. So suppose this is value is say 70. Say this is almost near to this, so this value may be 225. This value may be 125, and so on. So the intensity will increase. The blackness of a pixel is distributed over 0 to 255. That means 256 penny values it can take. That means white will take 0, and the complete black pixel that will take 255. And in between, depending on the blackness, if it is more black, then it will be towards this side. If it is less black, it will be towards this side, these values. Okay. In case of colors, there are many formats to implement. So one of the interesting and important format is RGB format. Red, green, and blue. Red, green, and blue. So what it says that every pixel must be of 3 coordinates, say R, G, B. Each of this coordinate, this RGB values, they should lie between this value. RGB should lie between 255. So you can think of any colored image can be represented by these 3 coordinates. For example, say this is say 100, 255, say 200. That means the intensity of red is 100, the intensity of green is 255, and the intensity of blue is 200. So that will represent a color. Any question?
Sir, I lost my connection, so I
Okay.
cannot hear.
Okay. So up to how much you heard?
I cannot see your screen.
Remaining students are able to see my screen?
Yes, sir.
So I think you just go log out and then log in. Then I think you will be able to see the screen again.
Now it's visible.
Now it's visible. Okay.
Yeah.
Okay. So what it says that any color C can be represented by this. So for mathematics students, it can be thought of like a vector space concept, like R3 over R. So what you understand that any coordinate, say x, y, z, can be represented in terms of three bases. There could be any basis, say 1, 0, 0 plus 0, 1, 0 plus 0, 0, 1. And if I put x, y, z here, then you can understand that this can be represented, this point can be represented by these three bases. So this is R3 over R is a three-dimensional vector space over R. So here also you can understand that this intensity value, this intensity value, say this could be, R could be one of the bases, G could be one of the bases, R could be one of the bases. So if you have like 100 into 100 plus 255 into 010 and 200 into 001, then that can be represented by a point on this color plane. So as any color within this range can be represented, any point within R3 can be represented by these three bases. Here also any color, of course it's finite, so it's basically 256 cross 256 cross 256. So at most this many colors can be represented. So any color from this range can be represented by uniquely by this combination of these three bases. Okay, so that's the basic idea of this concept of RGB channels. So there are another model of CMY. So I'm not going details of this, but anyway, for the time being, we shall deal with this gray label images. So for gray label images, we'll have only these values, like 0, some value V should be less than 255. Okay. Here, so a grayscale image, if you have some black and white grayscale image, I mean grayscale means looks like black and white, but you have a different shade of blacks. That's why it's grayscale. So each of the pixels, you can read each of these pixels. Okay, each of these pixels are having values 0 to 255. So each of these pixels will be considered as your secret, and then apply with respect to some modulo prime. So most of the cases, for the simple case, what I what I request you to do is that, suppose you have any grayscale image, first make a modification of this image. How? So this value is, we know that 251 is a prime. Suppose I take P to be 251. Now you can understand that if you deal with 251, then there might be some values like 251, 252 up to 255. These values will not be addressed by this P, because these values are more than P. If this could be a secret, then here this value will be 0. If this could be a secret, here the value is 1, and so on. So you can understand that these values will be not be addressed properly. So what you do, you from this, whatever may be the image, you just convert into another image in which all the pixels whose intensity value is more than 251 or greater than, more than strictly, whose value is greater than equal to 251, convert it into 250. That means, suppose this value is, suppose this intensity is 251, and say this is little darker than this is little darker than this, and say this is 251 is a complete black. Okay. Now you replace all of them by, say, almost similar looking. This is almost same as 251 or 255. So replace, convert another image whose intensity is at most 250. Okay. So if the pixel value is less than equal to 250, it's fine. You keep it as it is. If it is more than 250, suppose this value is 252, then convert this image, convert this pixel into 250, and so on. So that means your modified image, each of the pixels will be having intensity at most 250. Now apply this idea with this pixel with p value to be 251. So you will get some shares. Why I am doing it with 251? Because if the intensity p value is say more than, suppose 257, suppose this is a prime, then if you consider with 257, then some pixel value may be 256, but you can never express 256 as a pixel value, because pixel value must be within 0 to 255. So you cannot represent 256. As a result, the image will have some error. So you have to be within this range. So if you consider with p to be 257, then the problem will come here. So as a result, you cannot deal with this. That's why start with a secret image and convert it into an image which will almost look like the secret image. You cannot, by your naked eyes, you won't be able to distinguish between these two. Okay, then consider this your as a secret image and generate the shares. Each of the shares will also look like some image. This is random looking image. You will able to find that each of them will be some random looking images, and then from that images, when the qualified number of participants will join their shares, they will get back the secret, this modified secret image. Okay, is it clear?
Yes, sir.
Good. So now any question? So first I request you to do it only with integers, and then when you find it's done, then try to do it with images. Any question if you have, please let me know.
So for integer, then we need to input, I mean, in the program that our T, W, P, and K value, and we need to find the shares as our.
Yes, yes. Then secret reconstruction algorithm will take as shares how many shares you want to do. For example, if you want to have 3 shares, then it will give you the 3 shares, and from that 3 shares you generate A0 value, and A0 will be your secret. And if it is unable to solve, it will tell you that okay, no, not unique value, or unable to solve, less amount of information that I have, something.
Okay, sir.
Okay, then if not, then I will stop it here.